Hello everyone, welcome back to another episode of SMO Unlocked. I'm teacher Chishin, and today we'll be talking about the concept of separation of constants. And the questions that we'll be discussing is from 2017 SMO Junior Round 1 questions 35. And the question is, the number of seashells collected by 13 boys and 8 girls is n squared plus 10n minus 18. If each child collects exactly the same number of seashells, determine the value of n. So there's a lot of information in these questions. Let's look at it one by one. So from the first information we have, the number of seashells collected by 13 boys and 8 girls is n squared plus 10n minus 18. So from here we know that there's 13 boys and 8 girls. But now, what does n squared plus 10n minus 18 refers to? Yes, it refers to the total number of seashells collected by everyone. So, given that there is 13 boys and 8 girls, what additional information do we need to express the total number of seashells? We need the number of seashells collected by each child. But do we have the exact value of it? Let's look at the second information. So for the second information, we know that the number of seashells collected by each child is actually the same. But how can we express this in mathematics? Yes, we can express this as x, since it is an unknown value. So now we know that the number of seashells collected by each child is x. How can we express the total number of seashells collected? Some of you might answer that we can calculate the total number of seashells collected by boys and then add this up by the total number of seashells collected by girls. This is a very good approach. On top of that, for these questions, since we know that the number of seashells collected by each child is the same, we can actually calculate the total number of children first and then multiply it by x. So now, what is the number of children in these questions? Yes, it is n plus 13. So by multiplying this with x, we will get x times n plus 13. And from the questions, we also know that n squared plus 10n minus 18 also refers to the total number of seashells collected. So now, let's equate them together. So from here, we'll get x times 13 plus n equals to n squared plus 10n minus 18. And from what we have just discussed, x refers to the number of seashells collected by each child, and n refers to the number of girls. And this means that both of them are positive integers. So now let's observe on the equation. So from the left side, we know that 13 plus n is an n term. And we have also another n terms on the right side, which is n squared plus 10n minus 18. So now, how can we express x in terms of n? Yes, we can make it into a fraction of x equals to n squared plus 10n minus 18 over n plus 13. But now, we have faced a rather complicated fraction for us to solve. It's very hard for us to determine the value of n using these fractions. Let's look at some example before coming back to these questions. So for the first example, we have 5 over k is an integers and k is a positive integers. Now we want to find the possible value of k. So now, what is the relationship between 5 and k? K is a factors of 5. So in this case, what will be the value of k? Yes, it is 1 and 5. Let's move on to the second example. So for the second example, we have a fraction of 3k plus 5 over k. And with the same criteria as the first example, we want to find the possible value of k. So now we have a more complicated fraction, which is 3k plus 5 over k. Let's first look at the first example to see if there's any information that we can use. So for the first example, we can see that we are able to solve this directly by looking at the relationship between 5 and k. So now, for example 2, are we able to simplify these fractions into simpler fractions? Since there is an addition in the numerators, we can split it into 3k over k plus 5 over k. And since in the first fractions we have the same terms for numerators and denominators, we can cancel off the k for them. So now we will get 3 plus 5 over k. So since the question gives us that 3k plus 5 over k is an integers and 3 is also an integers. So what kind of number will be 5 over k? Yes, it is also an integer. So now, what will be the value of k in this case? Yes, it is 1 and 5. So what we have just did on example 2 is actually called as the separation of constants. When we split a rather complex fractions into an integers and a simpler fractions. So now let's move on to the third example. So for the third example, we have 16k plus 11 over 2k plus 1. This is a rather complicated fraction as compared to the previous example. And with the same criteria as the previous example, we want to find the possible value of k. So now, let's pause and think for a few seconds on how we can apply the separation of constants to simplify these fractions. Welcome back. So if we split these fractions directly, it's very hard for us to find the value of k. So now let's move back to example 2 to see if we can find out anything. So for example 2, when we split a complex fractions into an integers and a simple fractions, we actually split it into two simple fractions first. And from here in the first fraction, we can see that the terms in the numerators and denominators is actually the same, which allow us to cancel off each other to get an integers as a result. So to achieve the same result, if my denominators is 2k plus 1, what should also be my numerators? Yes, we should also include 2k plus 1 in the numerators. So now, let's observe on the original fractions. So on the original fraction, we have 16k. How do we achieve 16k from 2k plus 1? Yes, multiply it by 8. So from here, we get 16k from here and another 8. So how do we get from 8 to 11? Yes, add 3 in the numerators. So from here, we will get 8 plus 3 over 2k plus 1. So from here, we know that 16k plus 11 over 2k plus 1 is an integer. 8 is also an integer. So what kind of number would be 3 over 2k plus 1? Yes, it is also an integer. So now we also know that 2k plus 1 is a factors of 3. What would be the value of 2k plus 1? Yes, it is the factors of 3, which is 1 and 3. So among these two numbers, let's test one by one on which of these applies to the criteria that k is a positive integer. Let's first check 1. So now we have 2k plus 1 equals to 1. What would be the value of k in this case? Yes, it will be 0. But 0 positive integers? No. So in this case, we have to reject these options. Let's look at our second options. Now we have 2k plus 1 equals to 3. What will be the value of k in this case? Yes, it is 1. So is 1 a positive integers? Yes, it is a positive integers. So in this case, the answer for this example is 1. So now let's move on to the fourth example. So for the fourth example, we have k squared plus 11 over k plus 1. And with the same criteria as the previous example, we want to find the possible value of k. So from what we have learned just now, what should we do first? Very good. Do separation of constants. So if my denominator is k plus 1, what should also be included in my numerators? Yes, k plus 1 also. So from here we get k plus 1 as the numerators and k plus 1 as the denominators. So now let's observe on the original numerators. So from the original numerators, we have k squared plus 11. So how can we get from k plus 1 to k squared? Yes, multiply by k. So from here we get k squared from here and another k from here. So how do we get from k squared plus k to k squared plus 11? Yes, minus k plus 11. So from here we can get k plus 11 minus k over k plus 1. But can we solve the value of k using these fractions? No worries. Let's try to do another round of separation of constants for these fractions. So in this case, if the denominator is k plus 1, what should also be the numerators? Very good. It is k plus 1 also. So from here we can get k plus 1 over k plus 1 as a denominator and k plus 1 as a numerator. So now let's compare the original and the new. So on the original we have negative k. So how can we get from k plus 1 to negative k? Very good. Multiply it by negative 1. So from here we will add a negative in front of the bracket. So we'll get negative k, which is what we wanted, and another negative 1. So how can we get from negative 1 to 11? Yes, it is plus 12. So from here we will get k minus 1 plus 12 over k plus 1. So from the questions we know that k squared plus 11 over k plus 1 is an integer. K minus 1 is also an integer. So now we also know that 12 over k plus 1 is also an integer. So from here we can say that k plus 1 is a factors of 12. And what would be the possible value of k plus 1? Yes, it is the factors of 12, which is 1, 2, 3, 4, 6, and 12. So among these 6 values, which of it satisfied the criteria that k is a positive integer? Yes, all 2, 3, 4, 6, and 12 satisfied. And 1 does not satisfy because if k plus 1 equals to 1, k would be 0, which does not satisfy the criteria that k is a positive value. So now we just need to minus 1 to all of the remaining numbers, which will give us 1, 2, 3, 5, and 11. So now we have solved all of the examples. Let's summarize on this. So among the examples, we have learned a new concept which is called as the separation of constants. So now let's look at the criteria for us to satisfy in order to use this concept. Let's use some example as reference. So this include 5k plus 3 over k and k squared plus 3 over k. But before we look at the criteria, let's first look at a new learning point which is called as the degree of algebraic expressions. And this is basically the number of letters in each expression. So for the numerators for our first example, what is the degree of 5k? Yes, it is 1. How about k? It is also 1. How about k squared? Yes, it is 2 because k is squared. How about k? Yes, it is 1. So from here we can observe and conclude that in order for us to utilize separation of constants or the fractions, the degree of the numerators should be higher or equal to the degree of the denominators. So now let's move back to the question itself. So just now we are stuck at x equals to n squared plus 10n minus 18 over n plus 13. And we think that it is a very complicated fraction for us to solve. So from the example, we also learned about the separation of constants. But before applying that into these fractions, let's first check if we can use the concept in these fractions. So now, what is the highest degree for our numerators? Yes, it is 2. How about denominators? It is 1. So in this case, can we use separation of constants on these fractions? Yes, we are able to use it on these fractions. Let's do it together. So by using it, we will get x equals to n times n plus 13 over n plus 13. And by multiplying n into the bracket, we will get n squared plus 13n. But from our original fractions, we only have 10n minus 18. So how can we get from 13n to 10n minus 18? We can minus 3n minus 18. And this will give us n plus negative 13 minus 18 over n plus 13. But can we solve n directly using these fractions? No worries. Let's do another round of separation of constants to simplify these fractions further. And this will give us something like n plus negative 3 times n plus 13 over n plus 13. And by multiplying negative 3 into the bracket, we will get negative 3n minus 39. So how can we get from negative 39 to negative 18? We can actually plus 21 to the numerators. So in this case, we will get n minus 3 plus 21 over n plus 13. And from what we have discussed just now, we know that x is a positive integer. this means that n minus 3 is also a positive integer, which also means that 21 over n plus 13 is also a positive integer. And this also means that n plus 13 is a factors of 21. So now, what is a factors of 21? Yes, it is 1, 3, 7, and 21. And before that, we also know that n is also a positive integer. So among these four numbers, which of it satisfies the criteria that n is a positive integer? Yes, it is 21 only, because 1, 3, 7 are all smaller than or equal to 13. So in this case, what would be the value of n? Congratulations everyone, the value of n is 8. So for this question, the answer will be 8. So let's summarize on what we have just did. So on this video, we have learned about the concept of separation of constant, where we split a complex fraction into an integers plus a simpler fraction. On top of that, we also learned how can we determine if we can use separation of constant. And this includes the concept of the degree of algebraic expressions, where the degree of the numerators should be higher or equals to the degree of the denominators. So now let's check if you have fully mastered the concept of separation of constant using this practice question. So if you have already done these questions, please feel free to drop your answer down the comment sections below. On top of that, if you have any doubts or needs any clarification, please feel free to join our study group or contact me directly. Most importantly, don't forget to subscribe to our YouTube channel for more of such informative videos. So now, let's review the answer for our last practice questions. So the answer for this question is 12200. So for those who get the right answer, congratulations. For those who are not, no worries. Don't be disheartened. You can try to reach out for us in this study group or contact me directly for more clarifications. Thanks for watching.